So first of all, thanks for all the support on the last video. That meant a lot to me, especially since it was my first devlog. Speaking of devlogs, here's the second one, procedural trees. I'm sure we all know what the Fibonacci sequence is. That pattern we learned in 5th grade, 1, 1, 2, whatever, it's probably easier to explain. Each term is the sum of the two previous terms. The way it's programmed is using this concept called recursion. The way recursion works is having a method repeatedly call itself. To better understand, let's take a look at how this code branches out. In essence, to calculate the 5th number in the Fibonacci sequence, it needs to add the 4th and 3rd numbers in the Fibonacci sequence, and to do that, the function needs to call itself again to find those two numbers. But to calculate these numbers now, the function needs to call itself again to find the 3rd and 2nd and 2nd and 1st Fibonacci numbers respectively. Visualizing this gives us something called a recursive tree, and the thing about recursive trees is, well, they look like trees. Now we have the base layout for a 2D tree, but how do we go from a bunch of function calls to an actual tree? The whole system is based on a struct called branch data. The name is pretty self-explanatory, and all it does is contain a bunch of information about a single branch of the tree. The most important variable in the struct is root. This is an array of 3D vectors of length faces, dictating the position of each vertex of the shape of the trunk of the tree. To better explain, let's say we have a tree with 6 faces. In other words, if we look at the trunk of the tree from a bird's eye view, it'll be in the shape of a hexagon. The root array holds the positions of each of those vertices in the hexagon. Now we can move on to actually creating the tree in game. So to do this, we call the generate branch method, which is also the driver method used for recursion. First, the method creates a mesh for a specific branch. It does this by looping through each vertex of the entire branch and setting its position, then also adding 2 new triangles to the mesh. After this, the code randomly chooses whether or not to split into 2 different branches. The split is relatively simple. It essentially just creates 2 new branch data structs. In these, it uses the end of the first branch as a root. It then creates 2 new branches using these structs, and eventually this, after combining all the branches with this handy little method, we have a tree, or at least a tree without its branches. It's a little hard to wrap your head around, but essentially it just takes that recursive tree visualization and makes it 3D. Then at the ends of each branch, after it stops recursing, it adds some leaves, which is just a mesh that is either scaled up or down based on the size of the ends of the branch. The smaller it is, the smaller the leaves are. Now we have a finished tree, but it doesn't look great. I mean, the leaves don't look like leaves, and the trunk doesn't really look like a trunk either. For the trunk, I just used a Unity standard shader, and